So let's start our next section, which will be 14.4, which is about center of mass and moments of inertia. So really in this section, we're focusing on applications of double integrals. So let's start with mass. So we're going to talk about mass of a planar lamina of variable density. And so we're going to start with the formula. So if rho is a continuous density function on the lamina corresponding to a plane region R, then the mass M of the lamina is given by M. So it's the double integral over your plane region R, and you're going to integrate your density function. And then I put dA here because it could be dx dy or dy dx. So let's look at an example where we find mass. So find the mass of the triangular lamina with vertices 0, 0, 0, 3, and 2, 3, given that the density at the point xy is given by the function rho, which is 2x plus y. So the first thing we're going to do is we want to understand our plane region. So we're going to look, it's a triangular region, and I'm going to plot these three vertices here. So I have my origin, 0, 3, and 2, 3. We're looking at the triangle between these three. So here's my region. And so we are going to need to describe our region. So if I look at pieces vertically, well then my bounds on x would be 0 to 2. And my bounds on y would be y is at most 3. That's this top line here. Y equals 3. If you write the equation of this line right here, it'll be y equals 3/2 x. So to find mass, you could set it up as the integral of my density function, dA. So you can find it as 0 to 3, 3/2 to x, 3, 2x plus y, dy dx. Or you could set up the integral in the other order. So let's look at our region again, and how would I set up my integral if I switched the order? So I'm going to redraw my triangle here just so I have it. So now I'm going to look going horizontally. So now y is between 0 and 3, and x is between 0. And if you solve in our previous equation, right here, if you solve for x, you'll get x equals 2/3 y. So that's the upper bound there, 2/3 y. And so now I can set up the integral as m. It's the integral from 0 to 3, 0 to 2/3 y, 2x plus y, dx dy. Now this one, what's nice is both of my lower bounds are 0 here. So that means it'll be a little bit easier for me to compute. So I'm going to go with this one. M will be the integral from 0 to 3. So if I integrate with respect to x, it'll be x squared plus yx. And then plug in your bounds, top number minus bottom number. So it'll be 4/9 y squared plus 2/3 y squared. So if I add up 4/9 and 2/3, it would be 10/9. And then I just need to integrate y squared, which would be y cubed over 3 from 0 to 3. And then if you plug in 3, you'll get just 10. So my answer for the mass is 10 here.